The Milky Way is weird. I mean, really, all of space is weird. That's why I like it so much. But the more we learn about the Milky Way, the more we realize just how strange and wondrous it is. For example, did you know that we live in a giant cannibal and that there are ghost spiral arms haunting our galaxy? We don't even know really what shape our galaxy is. That's where we are with understanding the Milky Way. But thanks to the European Space Agency's Gaia spacecraft, we've been learning a lot more cool stuff about our home in the cosmos. Gaia has been creating the most detailed and precise map of our galaxy ever for the last decade, making more than 3 trillion observations of 2 billion stars. But now, it's time to say goodbye to Gaia. I'm Swapna Krishna, and today on Ad Astra, I'm going to break down the absolute weirdness of the Milky Way galaxy, what this observatory revealed, why we're retiring Gaia, and what might come next. All right, let's talk about how weird the Milky Way is. That's not to say it's significantly weirder than other galaxies, but because it's our galactic neighborhood, we can study it a lot more closely than we can other galaxies. But our location also presents challenges. One of the things we've been trying to figure out is the shape of the Milky Way. I know that seems super basic, but think about it. We've barely sent spacecraft outside our solar system. We've never seen the galaxy from outside of it. We don't have any pictures of the Milky Way. Think about trying to figure out the shape of a house, what it's made of, and its position within a larger city or state without actually being able to see the outside of the house. It's not easy. We've long thought that the Milky Way is a spiral galaxy, which makes sense because we think about 77% of the galaxies in the universe are spirals. But is it a regular spiral galaxy? A barred spiral? Are the arms tightly or loosely wound? How many arms does it have? 2, 4, 6? Or is it lenticular, which is basically a spiral galaxy with no arms? Gaia has helped scientists confirm that our host galaxy is a barred spiral. For a long time, we thought that the Milky Way had 4 prominent arms. Then, in 2017, data from the Spitzer Space Telescope indicated that the Milky Way was actually dominated by just 2 major arms with 2 minor arms. This is the best and most accurate image we have of the Milky Way thanks to Gaia. You can see the barred center of the galaxy, home to our dormant supermassive black hole Sagittarius A star. You can also see a lot more than 2 major arms. Instead, Gaia has shown us that the Milky Way likely has multiple minor arms. We're right here in the Orion outer arm, if you're curious, around 26,000 light years from the galaxy center. But we don't think the galaxy always looked like this. Scientists used Gaia motion data to identify structures moving through our galaxy, and the results are fascinating. Scientists didn't expect how many fossils and ghosts they'd find. In this map, you can see an all-sky map of the Milky Way created from Gaia data. The darker black and purple is areas of significant motion, while yellow is areas with low motion. The blue lines that are overlaid on the map are areas of significant motion mapped out by the study's authors. You can see the Magellanic Clouds on the left, while the Sagittarius galaxy is here on the right. Scientists think that these structures may be what's left of additional spiral arms that were disrupted by the many collisions the Milky Way has had with neighbor galaxies. They're in essence fossils or ghosts of the spiral arms that no longer exist in our galaxy. We've also learned that the Milky Way has unrepentantly eaten other galaxies again and again throughout its history. The Milky Way has grown thanks to these kinds of collisions with other galaxies, sometimes consuming those galaxies altogether. In 2018, researchers discovered that a specific group of 30,000 stars moved in a synchronized way in the opposite direction of the 7 million stars that surrounded them. The team was also able to see that these stars had a common origin that was different than those other stars around them, which led the researchers to believe that these stars were ripped from another galaxy, possibly the debris that resulted from a galaxy merger. Scientists think that the Milky Way may have merged with another galaxy, GSE or Gaia Sausage Enceladus, yes, I'm serious, sausage, early in its formation somewhere around 10 billion years ago. Another galaxy collision around the same time was likely responsible for the globular clusters that orbit the Milky Way's core in the wrong direction. But an encounter doesn't have to be so violent as a galactic merger for our galaxy to steal stars. Some scientists think that the Milky Way's unique shape may be the result of periodic collisions with the Sagittarius dwarf galaxy. It might be the reason that the spiral arms around our galaxy are not symmetrical. Sagittarius orbits the Milky Way's core, and we think it's collided with the Milky Way at least 3 times, most recently around 2 billion years ago. Every time this happens, Sagittarius loses stars to the Milky Way, leaving the sad dwarf galaxy even smaller. At some point in the future, the 2 galaxies will collide again, and there may be nothing left of Sagittarius, as the Milky Way is currently in the process of tearing it apart. One interesting note, though, is that stealing stars from Sagittarius isn't the only way the Milky Way has gained stars from the dwarf galaxy. In the aftermath of a galactic collision, concentrations of gas and dust increased. This led to increased rates of star formation. One of these bursts of star formation occurred about 4.7 billion years ago, which is when our own star, the Sun, formed. So the Sagittarius dwarf galaxy may have been responsible for us being here today. One especially interesting tidbit from Gaia is that parts of the Milky Way are truly ancient, much older than scientists would have ever expected. Science tells us that the Big Bang occurred about 13.8 billion years ago, as far as we know, and for a long time, the assumption was that the Milky Way took almost 3 billion years to start forming. Well, now thanks to Gaia, we think it was much earlier than that. Scientists used Gaia data combined with data from China's Large Sky Area Multi-Object Fiber Spectroscopic Telescope to derive the ages of around 250,000 stars. There are a few different parts of the Milky Way. There's the disk, which surrounds the halo. The bulge is the central part of the galaxy, while these globular clusters are groups of ancient stars that orbit the galactic center, but above and below the pancake plane of the galaxy. Now, the disk has basically 2 different parts, the thin disk and the thick disk. The thin disk is what we normally think of as the Milky Way, the thin band of stars you can see across dark skies. The thick disk is much larger than the thin disk, but it contains many fewer stars. By comparing ages of stars between the two, scientists discovered that stars began forming in the thick disk less than 1 billion years after the Big Bang, specifically 0.8 billion years after the Big Bang. The inner part of the halo may have also begun forming at this point. But the Milky Way really got going after that aforementioned collision with Gaia, Sausage, and Enceladus, which triggered intense star formation. Some of the stars at the core of the Milky Way are so ancient that they don't contain many heavy metals because these hadn't been created yet. Scientists call this area of the galaxy the Milky Way's poor old heart because the stars in the region are so metal poor. This is just a snapshot of the many things we have learned about our galaxy using data from one telescope, and often combining Gaia's data with that from other telescopes. There's so much more I haven't mentioned here. Gaia found a dormant black hole within our galaxy less than 2,000 light years away. It's the 3rd dormant black hole found with Gaia data. So you might be asking, if Gaia has been this productive, why is the observatory being retired? The Gaia Space Telescope launched in December 2013. It's a fully European mission, a product of the European Space Agency. Gaia was designed to create a 3-dimensional map of the Milky Way. It's cataloged almost 2 billion stars in the galaxy, taking note of their luminosity, temperature, and composition. It also tracks their motion, which is not an easy thing to do, considering that Gaia itself is constantly in motion as it orbits the Sun at Lagrange point 2, about 1 million miles or 1.5 million kilometers from the Earth. This allows the spacecraft to take observations without passing into and out of Earth's shadow. Gaia actually has 2 onboard telescopes that between them have 10 mirrors to focus light onto the science instruments. Gaia relies on its astrometric instrument to determine positions of stars in the sky using both parallax and proper motion. The radial velocity spectrometer measures velocity, while the photometric instrument provides color information for stars, from which scientists can derive mass, temperature, and chemical composition. Gaia uses all of these instruments in combination to create its 3-dimensional map of the Milky Way. But creating this kind of map means that Gaia has to spin and scan the sky. The telescope relies on a cold gas propellant to do so, and the gas is running out. As of January 15th, 2025, Gaia's mission is over. Its science observations are finished. This isn't the end of Gaia. There are 2 more huge data releases coming, and scientists will continue to use the observatory for technical tests that will allow them to gather data to improve future spacecraft. Once those are concluded, Gaia will leave 3 for a heliocentric orbit, an orbit around the Sun, and the observatory will be fully retired on March 27th, 2025. It is truly a send-off into the sunset worthy of this telescope. So what's next for the study of our galaxy? Well, the Gaia releases will go through the end of the decade, and there are still some major mysteries about the Milky Way scientists are hoping can be solved. We're expecting the next Gaia dataset, DR4, in mid-2026, and there will be 66 months of data in that release to go through. DR5, which is expected at the end of the decade, will have a massive 10.5 years of data. There is a planned successor for the Gaia Space Telescope, the Gaia Near-Infrared mission, which would survey 12 billion stars in the Milky Way and would launch in the early 2030s. It's not clear yet if this will happen though, but we will see. But for now, that is all I have to say about the Milky Way and the Gaia Space Telescope. Thanks for watching. I am Swapna Krishna, and this is Ad Astra.